Alright class, so welcome to 5.2, the unit circle. So we're getting into the thick of the trigonometric functions, and we're going to talk about sine and cosine today. Okay, so this is our first definition. When you took the trig class, you actually learned 3 different definitions for the sine, cosine, and so on, all the other trig function values. They're all, of course, based on sine and cosine, but you've learned 3 different types of definitions. So the first one, in fact, that you might have learned, depending where you took this class, was that, okay, given angle theta in standard position, and one more time from last time, what does it mean, standard position? An angle in standard position means that the initial side is on the positive x-axis. Yes, terminal side could be wherever he wants to be, but that's the main part. And of course that the vertex is in the origin, yes, of the xy plane. Okay, so given that, what we can do is we can draw a circle of any radius around this. So let's call this radius some kind of r. And then by definition, we said, okay, well, let's say that the sine value of this angle theta is simply y over r, where y is the y coordinate of the point where this terminal side crosses through this circle, yes, and r is the radius. Now, sure enough, just to show you, and let's just say what the cosine value of it is. The cosine, we're going to pick the x coordinate of it, so x over r. Now, sure enough, that easily transforms into a second definition that you have learned. That's actually the second one. That in fact, if I draw this right triangle right here, what did you learn the sine value of this angle theta is? It's the opposite side in this triangle, and the opposite side is really just the y coordinate, right? Because it's a y distance from here to here. So it's y over the hypotenuse, but what's the hypotenuse? Well, that's the radius, yes? So you've learned that the sine value is the opposite over hypotenuse, and then the cosine value is the adjacent, and the adjacent is what? It's an x distance from here to here, because if that's the x coordinate, then that means from here to here is a distance x, so it's the adjacent over the hypotenuse, which is r. Great. Now, as I explained last time, it really doesn't matter which circle you are choosing, because these ratios are going to be proportional to each other. So the larger the radius, the larger these y and x values are going to be. However, these ratios are going to be proportional. So something like, let's say, a radius 2, and then the y value turns up to be 10. If I pick a circle of radius 3, the y value is going to turn out to be 15. And it doesn't matter, because all reduced down, that's simply just the 5 over 1, yes? Which, by the way, that's not going to make sense. For the sine value, just saying the ratios, of course, y has to be smaller than r, so I should have put them in a different order. But 1 to 5, then fine, 2 to 10, or 3 to 15, right? The y value has to definitely be smaller than the radius, right? Okay, either way, that's what I'm saying, they're proportional. So if they're proportional, we might as well make this computation easier and pick what we call the unit circle. And what is a unit circle? A unit circle is simply a circle with a radius that equals to 1. So on a unit circle, what do these definitions become? So I'm just going to pretend, well, there it is, and I've scaled this circle down to a radius of 1. That means it's just all 1 unit up to there, and it's 1 unit up to here. That means this is -1, and this is -1. And then what do our ratios become? Well, if the radius is equal to 1, then the sine value is just the y, and the same thing, the cosine value is just the x coordinate. And then I have to play with just 1 number rather than with 2, right? It really wouldn't matter. The answers for the sine and the cosine values are going to be the same. Okay, and that's our third definition, and really the most helpful one for these sine and cosine values. So Why is this the most helpful one? Because something else we talked about last time, and I'm going to say this. If the angle theta is in radians, and remember, we can switch from radians to degrees and backwards at any time, but specifically if the angle theta is in radians, we learned this formula. S is equal to R times theta. What was S? S was this distance on the circle, right? From the initial side to the terminal side, but it was the length of this arc, yes? Okay, but if you are on the unit circle, what is R? R is equal to 1. So then what does this formula become? This formula simply becomes S is equal to theta. Okay, so specifically on this unit circle, I have these definitions. That sine of theta is the same thing as sine of this value S. And the x-coordinate there is the cosine value of this number S. What does S represent? S is simply the distance from where? From this point here, that's the point of coordinates 1, 0, yes, from that point of coordinates 1, 0 to the point of coordinates x comma y, right, on the circle. And all of a sudden, our sine and cosine functions don't have to actually even be about angles. They could be about numbers or about distances. So to find the sine of this angle theta on a unit circle is the same as finding the sine value of this distance s from 1, 0 to xy along the circle. The values are the same. So, in other words, we can finally, define sine, by the way, it's sine, and cosine, but that's the short version of, that's the shortcut, like logarithm, we just write log instead of the whole thing, but these are the names of these functions. So we can define sine of cosine in terms of real numbers. In other words, we can make them functions, and I'll explain in a minute. So we can make them functions. This is why it's so important. So we can make them functions. This is why it's so important this is why this is the most important definition, right, of the three that I presented for you. Because we can define sine and cosine in terms of real numbers. So sine of some kind of value s, I'm going to call it s for now, is equal to what? So sine is the y-coordinate of the point on the unit circle at a distance of s units in a positive direction, or I should say if s is positive, you go in a positive direction. If s is negative, you go in a negative direction. At a distance s units from the point of coordinates 1, 0. So let me show you, where should I go? I'm going to go down here. What does that mean? What, for example, I'm going to go up here. So for example, what would be sine of the number 3? All I have to do, so the number 3, right? That's a real number. All I have to do is draw myself a unit circle. So there's 1, 1, negative 1, negative 1. Why do I write 2? I don't know. So that's 1 unit long, yes? And then start at this point of coordinates 1, 0 on the unit circle and move by 3 units. How much is 3 units? Well, if this is 1 unit, 3 units is, again, it should be circular, about here, and actually I'm gonna fall short because I know that's a pi, which is 3.14. So again, if I'd be really good at drawing, this would be nicely scaled, it would make more sense. My 1 here is way fatter than this one. But I'm going 1, 2, 3 units. This is how much 1 unit is, yes? This is how much 1 unit is. So I'm moving 3 units along the circle. And then what do I have to do? I arrived at some point. What do I do at that point? I have to grab the what? The y-coordinate of that point. What's the y-coordinate of that point? That's the sine value of this 3. So to grab the y-coordinate, all I have to do is go back and read the y-coordinate of it. So I'd say sine of 3 might be about, again, it goes as high as 1, might be about, I don't know, 0.2-ish. I don't know, check your calculator and see if I'm right. Now, what is cosine of 3? Cosine of 3 means the same thing, means 2. Go along the circle from this point on, 3 units long, yes. And then grab the what? The x-coordinate of this point. So you grab the x-coordinate of this point. Great. What's the x-coordinate of this point? I don't know, let me go read it. The x-coordinate means to go back and look at the x-axis. I'd say my guess is maybe, I said for the sine value, maybe a 0.2-ish. For the cosine value, maybe a negative 0.9-ish. Yes, it's close to a negative 1. So again, put in your calculator. It will tell you exactly how much that is. I'm curious. Okay. So that's how you find sine, cosine of any real number. It doesn't have to be of 3 degrees. It doesn't have to be of 3 radians, of the number 3. Okay, so let's say you will have some of these homework questions that will give you a circle. And you will say, okay, here is the unit circle. So important that you're in the unit circle and not something else, because if you're not on a unit circle, that r does not equal to 1, so s does not equal to theta, right? So if you're on the unit circle, it says, okay, here is a point, and let's say this point has coordinates 0.37, and a y-coordinate of 0.89, and I'm not sure that that could even be possible. We'll talk about what that means in a second. And then it shows you an angle theta here, and it says, can you tell me what sine of this angle theta? Well, nothing easier than that. The sine value of this angle theta is going to equal to what? The y-coordinate of this point. The cosine value of the same angle theta is going to equal to what? The x-coordinate of this angle theta. Yes? So again, I made up those numbers, but I bet you that can be. Again, these are points that are going to be on a unit circle, right? So they have to satisfy a very important condition, and that's what we're going to get to right now. But that's as simple as that. Grab the x-coordinate for the cosine. Grab the y-coordinate for the sine. So what's so important about the unit circle? Let's get back to that. Why can some things be not possible? What do I mean by that? Well, what's a unit circle? Again, is a circle of radius 1, yes? Okay. So if I have a circle of radius 1, what is the equation of a circle with a radius 1? And you hopefully have learned equations of circles in your algebra classes, and if not, it's really not a big deal, because the equation of a circle is really easy to figure out. And it comes simply from Pythagoras' theorem. So if I draw this circle, that's going to be a right circle, as I had explained for you earlier. From here to here it's a y, right? Because that's the y coordinate. From here to here is an x because that's how much the x coordinate is. And the radius is 1. So what does Pythagoras' theorem say about these three sides and this angle? Nothing easier than the fact that x squared plus y squared is equal to 1, right? So that's the equation of the unit circle. And what does it mean that's the equation of the unit circle? It simply means that I don't care what point I pick on this unit circle, and I'm looking at its x coordinate and its y coordinate, they all have to satisfy this equation, that the x coordinate squared plus the y coordinate squared is going to always equal to 1. That being said, we are coming up with a very important equation that's going to relate the sine and the cosine values. What does the what does the x coordinate equal to? It equals to the cosine value of some angle theta. What does the y coordinate equal to? It equals to the sine value of this angle theta. So for any angle, where I'm going to say this, for any value, angle or not, real number or not, degrees, radians, simply real numbers, for any value, theta, this equation always holds. And what do I mean by this equation? That the cosine value of this number, square it, plus the sine value of this number, square it, is equal to 1. So just as a side note, why did I say that this is not possible? Square this number, add them together, they're, I'm sure, not going to equal to 1, right? So that's why this is not a possible point on a unit circle. I just made up those values. Okay, so we're going to write this a little bit better, just more mainstream. So who are you squaring? Are you squaring the angle, or are you squaring the values? You are squaring the values of them, the x and the y. Those are the values of these numbers, right? So not the 3 or whatever I put here, not that number, the angle, but what the coordinates are. So you're not squaring the angle, which is why we're going to write this a little bit. Doesn't make sense to write cosine theta squared. Why? Because that means that what? That we square the what? Theta, right? So it looks like we're squaring theta. We're squaring the cosine value, but we get lazy and we don't want to write that much. We don't want the parentheses. So to avoid confusions, we're going to put that square on top of cosine. And that now means that we are squaring what? The cosine value. So you put that number inside the cosine, and then you square that answer. Okay? So plus sine squared theta is equal to 1. Great. I know x comes first and then comes y, but, and it's, I know, a little bit confusing, but we are always like to start with sine, even though sine is the y value. So you're going to moreover see this equation written as sine squared theta plus cosine squared theta is equal to 1 in this order. It's not wrong to write it, the addition is commutative, but this looks prettier. That's the mainstream formula. That's how you will see it written. And again, it doesn't just have to be a theta, right? It could be a what? Could be an x, could be an angle A, could be an angle alpha, whatever it wants it to be, but it's a value, right? And it's important that it's the same value. So sine squared of some number plus the cosine squared value of that same number is equal to 1. Well, where did that come from? It came from this equation. Where did this equation come from? The fact that we drew this triangle and we used Pythagoras theorem for it, which is why this is called the Pythagorean identity. Now, in an identity is simply an equation that's always true. Something like x equals to x, yeah, that's always true, no matter what you plug in for x, right? So it's kind of like a formula, yes. All right, so there it is. This is our formula. Let me start erasing a little bit. Now you know how to find the sine cosine values, what they mean, and the most important identity between them. So, yes, what we want to do is find sine cosine values of important angles. Okay, and what are the important angles? Well, the easiest angles we can find these sine cosine values for are the 30 degrees, 45, and 60 degrees angles. And I don't really want, I can show you where a 30 degree angle and a 60 degree and a 40, fine, I'll show you. So if you start with an isosceles, an equilateral triangle, right? That's a 60, 60, 60. So all the sides are the same. I'm going to say that this side is 2, and the reason why I'm making that is to simplify because I cut this here in half, and then if this is 2, this side here is going to be a 1, yes? And then using Pythagoras theorem, this side squared plus this side squared has to equal to this side squared, so easily done. You would find out that this side here is a square root of 3. So it comes simply from a 30, 60, 90 triangle, and then let's just use those definitions that the sine of this angle 30 is going to equal to what? The opposite, which is 1, divided by the hypotenuse, which is 2. So hopefully you remember that value. What is sine of 60 degrees? Sine of 60 degrees is the opposite, which is square root of 3, divided by the hypotenuse, which is 2. So these are exact values for these angles. And we only could do that because we could start with an equilateral triangle. Now, on the other side, what's cosine of 60 degrees? I'm going to do that. Cosine of 60 degrees is its adjacent side over the hypotenuse. So that's 1/2. And then cosine of 30 degrees is equal to adjacent side, which is square root of 3, over the hypotenuse, which is 2. So sure enough, what I wanted you to see is that sine of 30 degrees is the same thing as cosine of 60 degrees, and that is why. Because the opposite side to 60 is the adjacent side to, the opposite side to 30 is the adjacent side to 60. So we're using the same two sides in this ratio, right? And now you also know why these functions are in fact called sine and cosine. So what do I mean by cosine? Where does the cosine get its co? That's because it's the complement of sine. So we call these complementary angles, which means what? Sine of some kind of angle, let's say 10 degrees, is equal to cosine of what? The complement of this angle. And what's the complement of 10 degrees? Well, that would be 80 degrees, yes? So that's why the word in cosine, they're complementary functions of each other. So just to practice one more time, sine of 50 degrees would equal to what? Cosine of the complement of 50 is 40 degrees. degrees, yes? So that's why. Okay, so once you know one, you know the other. We can use another important or easy to figure out triangle, and that's the 45, 90 triangle. And what could I figure out of that? If I call this side by 1, this one's going to be also 1 because it's an isosceles. And from Pythagoras' theorem, we can make this a square root of 2, right? 1 squared plus 2 plus 1 squared is square root of 2 squared. So sine of 45 degrees is the opposite over the hypotenuse. And by the way, cosine's just the same, not only because these are complementary angles of each other, but cosine of 45 is the adjacent, yes, which is also 1, over the hypotenuse, which is the square root of 2. But for both, and for all these problems, they will have with always one to rationalize our denominator. So that's more like the value of it. That's the way you will have it memorized. And I'm sure you already have it memorized. Okay. So I'm going to do one more thing and then I'm going to stop this video. Sine and cosine values of important angles. So I'm going to refer myself just to the first quadrant. So not just 30, 45, and 60, which are first quadrant angles, right? They're acute angles, but I'm also going to use 0 and 90, and these values easily come up out of a unit circle. So if you think about what? The sine value of an angle of 0 degrees, yes, around a unit circle. So this is an angle of 0 degrees. The sine value is the y-coordinate of this point, and the y-coordinate of this point is 0, yes? Sine of 30, we have it 1/2, square root of 2 over 2, square root of 3 over 2. And for 90 degrees, this is an angle of 90 degrees. Yes, I'm stopping right here. What is the y-coordinate of this point? Well, the y-coordinate of this point is 1. Okay, great. Now, what's the cosine value of all these angles? Well, they're all in fact complementary of each other, yes? 0 and 90 are complementary, so cosine of 0 is the same thing as sine of 90. So what you get to do is you get to write the above line all in reverse. So these are the values for the cosine, okay? Now, there's many ways of memorizing this. You can draw yourselves triangles, but you won't have time for it. What you want to do is know these angles and these values just like that, really quickly. So you might want to make yourself this table over and over and over again. I'm going to show you one quick way of figuring this out quickly. So again, you can make these tables for yourselves at any time. So what can I do? I can fill in these values and I can do what? What I will do is I will write the numbers 0, 1, 2, 3, and 4, right? So in order, 0, 1, 2, 3, 4. Great. Then what am I going to do? I'm going to take the square roots of them all, and I'm going to divide them all by 2. Okay, so what is the square root of 0, which is 0, divided by 2? That's a 0. Square root of 1 is 1, so that turns into that. That's square root of 2 over 2, that's square root of 3 over 2. But what does the square root of 4 equal to? Square root of 4 equals to 2, and 2 divided by 2 equals to 1. So that would be one way. Again, you can try and have this memorized or like start filling it in for yourselves really quickly. But yeah, I'm going to stop the video now and I'm going to make another one for you on reference angles.